You are now listening to the Big Data Beard. Hey everybody, this is Cory Minton from the Big Data Beard podcast, and we are at Data Science Salon in Austin, Texas, at Dell's headquarters, and actually Round Rock, Texas, more appropriately. And we are actually joined by the director of AI for Dell, David Patschke. David, how you doing today?
Great, Cory. Brett?
Must be pretty nice to be at a conference at your office. That's pretty convenient.
Yeah, it definitely makes it a little bit light on travel. So
helps with the emails and all of that as well.
Yeah, I was doing a little bit of that before this.
That happens. So, David, tell us a little bit about what you do for Dell.
Okay. Yeah. So actually, I am a director for AI and machine learning strategy, specifically targeted around precision workstations. So looking at how we can make our workstation offerings an ideal offering for helping execute AI and machine learning workflows. So I think there is a lot of movement around being able to execute these workflows in the cloud, but still, I mean, kind of me as an old school person, and I think most data scientists as a whole still like having that data locally and working with it locally. And but there's a lot of tooling, there's a lot of software and ecosystem around that. And so, what can Dell provide? You know, on top of its world-class hardware, who can we partner with from a software ecosystem perspective in order to help accelerate productivity around AI and machine learning projects?
Nice. Well, when you talk to data scientists, I think most of us, you know, when we have started tinkering with machine learning and some of the modern kind of AI technologies, I think pretty much all of us start with our laptop or our desktop, and then we run into some challenge. Like, how important is it when you talk to data scientists? How important is it to really have just an awesome machine for really getting those workloads kicked off?
So the way that I typically phrase this is as a data scientist, and my background was actually doing data science for probably about the last decade before moving into more of the strategy role. And the way that I always phrase this is, as a data scientist, I'm always used to working around constraints. I always seem to hit run up against memory bottlenecks, processing bottlenecks, whatever. And so I'm used to working around constraints. And the more of a machine that you give me, the happier I'm going to be, and the fewer constraints I'm going to have to work around. So that means more time actually working and solving the problem at hand. So whenever it comes down to, should I spend a little bit of extra money here or there? I've always found that, that extra grand or two on a little bit faster processor with a few more cores, or that little bit higher end graphic card ends up making a difference.
Yeah, so when you're talking constraints, and obviously computational power is a big thing for AI and machine learning, accelerators, right? They're all the rage now, GPUs, FPGAs, all these different types of accelerators. Can you talk a little bit about the importance of them, and do you always need to have an accelerator for your model development?
Yeah, no, I think that's a good question, Brett. I mean, I think right now people are familiar with accelerators, and particularly around the deep learning revolution. Something that I was mentioned late last year, and has there's been a pretty big push for is NVIDIA has started to release their Rapids platform, and the Rapids is for executing machine learning workloads on there as well too. So anything from like data, the kind of that first step, first mile of data ingestion, aggregation. And then also from a machine learning perspective as well too, they've done some stuff underneath the hood to accelerate XGBoost, which is gradient boosting algorithm that's kind of the popular go-to algorithm on Kaggle competitions. And so what was once just hey, let's use accelerators for deep learning, I think is starting to morph into that. One of the huge limitations around accelerators is always available GPU memory, because you want as much of your data to be residing in memory as possible, because the transfer back and forth of data from the from the main system to the GPU can be a little bit of a constraint. But with the next round of NVIDIA's cards, they're coming out with larger GPU footprints, and so that is that's making that could kind of change the game in terms of of moving from deep learning as well now to kind of doing the whole stack of machine learning and again, accelerating data aggregation in that first mile process as well too.
Cool. I want to dive in a little bit more into this idea of like memory constraint with GPUs. Can you give an example of, I think of like high resolution pictures where you get to a certain size where you actually can't put it into the GPU. Is that kind of what you're talking about as a constraint, or give us an example?
Yeah. So I think when I'm thinking about constraints is more from a kind of relational data standpoint, right? So if I'm wanting to do joining data from multiple different data sources and come in, right, that there's going to be, memory overhead on that. There's also going to be memory overhead on doing, feature engineering as well too on some of those columns. So I think it could hit several different aspects of, a lot of times if you are using some of the consumer graphics cards that have a lower GPU memory footprint, sometimes if you're doing some of the high quality video stuff, you can do a batch size of 1, and that might not necessarily help your models converge to that right, the kind of the optimal point. And so that's so around right, again, constraints. More GPU memory, the better. More CPU memory or regular memory, the better.
So it's interesting because one of the things that we've seen as constraints in general across, IT for years was like any IT workload, could be AI, could be anything else, was storage, right? Mm-hmm. And the ability for a storage subsystem or storage in a desktop or in a laptop or in a server to be able to serve the needs of processor quickly enough, which is why you needed large main memory buffers to handle that kind of dealing with that problem. But there's been a lot of evolution in storage over the last few years, and the speed at which storage is providing data access and data throughput around things like flash and others. Are there storage technologies that you think are uniquely interesting in AI and machine learning in the context of like desktop computing?
Yeah, from a workstation perspective. It's interesting. I think the whole NVMe aspect of storage was something I remember. Gosh, I guess now it's been maybe 2 years ago. Mm-hmm. I way overpaid on some NVMe storage because I read about that and said, hey, this actually could end up making a difference, and it does. The problem is at that time it was so expensive, so I think I only got like 512 gigs, and then was able to. So my data set was somewhat limited. But I remember noticing a difference at that time of being able to swap, data from, memory from disk to memory, mm-hmm. and get a speed up. So, yep, that's for sure.
The other one I'm looking at is, like storage class memory. I think it's going to be kind of interesting.
Okay.
As it makes its way into the world. That's going to be one that's still a few years out in terms of really broad adoption. Mm-hmm. But as a data scientist who actually practiced in the industry, and then now from a strategy perspective, you talked early on how it's like, people start in the data center or they start in the workstation, right? And they begin, toying around, playing, learning. But when they move towards actually developing something useful, typically a lot of those workloads need to be picked up and run in a data center, in a cloud somewhere. Are there specific technologies that you're seeing that like make that easier, like around orchestration and management of machine learning and AI workloads that you think help bridge the gap between that data scientist that's working on this workstation and wants to scale that out eventually?
Yeah. No, I think there are some pretty interesting technologies that are starting to come around that. I mean, of course, you have the whole revolution of Kubernetes, and then Google's kind of all in on Coop Flow, which is the machine learning and kind of distributed framework to be able to scale out. I still think that while that's maturing rapidly, there's still a place in the market for kind of capturing that, from an enterprise perspective. Mm-hmm. So, at least from what I've seen, right, Coop Flow is very, geared towards kind of Google and Google Cloud Platform and their platform. And what I am interested in is kind of who's going to be that enterprise leader in potentially Coop Flow. I mean, when you think of, okay, what did, Cloudera and Hortonworks do for Hadoop? Mm-hmm. Is there someone that can be that leader in that space, around a Coop Flow or this just distributed machine learning offering. And I think it's interesting to see what can happen. So, but obviously, container technologies, I think are great. Going back to kind of circling back around Rapids, I know that Rapids is heavily using a Python parallel processing tool called Dask, and that there's a lot of promise in that as well too. So when you're talking about, hey, I can use Dask and I can wrap my code using Dask and I can run it on the workstation, or then I can put it into a data center and then distribute it, and run it using Dask around what I have available in the data center. It makes the data scientist's job a heck of a lot easier. It's just a matter of configuring what you have available on the back end in order to be able to execute.
Yeah. So you hit on that. So data scientist jobs are pretty hard today still, right? It's still not an easy job that's there. So I'm curious, what do you think as you look across the landscape of tools and technologies that a data scientist has to use to execute their task, right? Of finding good data sources that can help them find predictive outcomes that drive some business value. What do you think are the next innovations that have to happen in this AI ecosystem that's really going to just accelerate adoption of AI in the enterprise and really move us forward rapidly?
Yeah, no, that's a good question. And actually the answer to that is something that I'm pretty passionate about because I don't want to say like this, but the kind of the sexy part of machine learning and AI, there are a lot of eyes on that. And I don't want to say it's solved, but at least from a business use case perspective, it's like, if you're not doing any of this right now, then the algorithms out there to at least get your feet wet, they're there and they're good enough. The question is, right, your first mile of data ingestion and your last mile of data deployment, right? So one of the things that I like to say around the first mile when you're thinking about, okay, what is the first mile, or what does data ingestion mean? I've kind of come up with an acronym called kind of like making data come alive, right? And alive stands for aggregation. So how are you going to join different sources? L is lineage, right? Because you want to be able to track any changes that you make to that. I is ingestion. How are you going to get that into your system in order to be able to actually work with it? V is validation, because there's tons of errors in data. And then E is enhancement or engineering, right? How are you going to create additional features to, again, make data come alive that you're going to put into your models? And then lastly, on the tail end, if you are not able to deploy those models, you're just basically taking part in a research project. So the idea is, what do we have to do in order to be able to make it as simple as possible? Because at the end of the day, all those are like, they're all buzzwords, right?
Oh, yeah.
AI, machine learning, data science. When you break it down into what each one of those disciplines produce, they produce a model, and that model has to be consumed by the business or by an end user in order for it to be useful and transformative. So what is it going to take to be able to do that? So when you're talking about ecosystem plays, my question is, okay, what tools are going to be out there that are going to make it really easy for data to come alive? And then what tools are going to be out there to make it almost seamlessly available to deploy those models in order for it to transform businesses? So I think that's still right. There's a lot of people, the fascination of the mathematics and just the ability to kind of create these models is what attracts and what mystifies. But man, there's almost a lot more, mystification on the front end and on the first mile and the last mile than there is in the middle. And I think more attention paid to that is going to be really the key to making this become more mainstream.
I really like that. Make data come alive. That is perfect.
Yeah, that acronym is good. And actually, you hit on something which is we've talked about it a bunch on this show. Is that there's, as you said, there's two ends of that spectrum. The ingestion side, where even still today, the majority of analysts say that data scientists spend 80% of their time cleaning and getting data ready algo development is a very small part of it. And then the flip side of that is like once you have an algo, put it in the ops. So there's this kind of like ML ops kind of hashtag going around on Google. There's a couple companies that are startups in that space where I agree that if they can help innovate there, I think it's going to be hugely useful.
Yeah, I think the focus has been really on that model development part of the last couple of years, and not on the wrangling or the putting into production.
It's cool, right? Or
It's the
sexy.
second.
which I don't know why. It's
I think
still just data.
I think data wrangling is really sexy.
Yeah, there you go.
Said no one ever.
Yeah, exactly. That's right.
So I'm curious with Dell, going back to Dell, and Dell's been around for a long time. They've done a lot. Dell getting into the AI game is not a new thing, but it's still relatively new. Can you talk a little bit about what Dell's overall strategy is with artificial intelligence?
So I'm mainly focused on workstations, but that doesn't mean that I don't have a broader picture as well too, or that workstations are just an entity unto themselves. Like really, I think where Dell stands apart is like we really are truly an end-to-end provider. And when you think of data being stored in a data center. So we have the data storage aspects of things, of the equation. If you're wanting to scale out on big data, right, we've got the servers in the data center to be able to do that. If you're looking at data scientists being able to kind of stratify their data, build some smart early models. We have workstations that have the horsepower to be able to do that. And then all the way down to, edge or IoT devices. If those need to be companies need to deploy models to the edge, right? We have that in that entire landscape. So the question then is like from an ecosystem perspective, where do we need to tackle? What do we need to focus on that? And I think we touched upon that a little bit earlier with containers, that the ability to encapsulate all your dependencies within that container unit, being able to work on that workstation, but then farm it out to a larger data center with more compute resources, to build a model that then encapsulate that model within a container to be able to ship to edge devices. That there is that whole container ecosystem is something that is really going to it's really going to help Dell help customers in terms of being able to execute in the AI and machine learning projects. I want to go back actually to there was a question on the ecosystem, and so we talked about some of those technical pieces. I think one thing that's lost as well too in that is really defining a good problem that is going to transform the business. I think there's a lot of times that what I've seen and been my experience is you might tackle a problem because it's easy to solve, or you think that it's there. But if you aren't involving the business owner, or you aren't involving that product owner there, that helping clearly define what is going to be useful to salespeople or to support technicians or to forecasters. Hey, if you're not supplying the right information and not starting with the right problem, like it really starts with the problem. So forget about the don't forget about the ecosystem, but let's get a good problem first and then move to that.
Finding the use case and then backing yourself into where in the ecosystem is going to help build out that use case. What's the data source? What's the software?
Absolutely.
Is that kind of what you're talking about?
Absolutely.
Yeah, and it's funny because I think you said it too, that so much of the tech is figured out, right? I mean, there's models out there. There's model automation tools out there that help if you have good data, right? That can help you find the models. There's a lot of work to be done in the data ingestion world, but I think you nailed it when you say that the business use case is the starting point.
Absolutely.
And without that,
absolutely.
Because the flip side, and one of the times data scientists and people in the technology part of it, we get excited because we're like, "Ooh, it's tech." But there's two problems. One, if we don't have a use case, then it's hard to justify. And then if we've got tech and we didn't justify, then it's hard to stick around very long.
So solve the right problem. Solve the right problem that's going to transform the business. And that is, and that absolutely 100% includes the business owners. So the data scientists are not going to magically come up with it unless they are solving the right problem.
Yeah, absolutely. So prior to Dell, you did some work in the data science field. You were a data scientist. You mentioned Kaggle earlier. Have you done anything with any data sets from there? Or can you tell any stories about when you were a data scientist?
From
the good old days.
Yeah. So thinking back, like I first started off in the financial world. Doing some algorithmic trading models. Did that for a while, then moved to a education startup in Austin. was a data scientist there, kind of helping build out their machine learning pipeline.
Mm-hmm.
And then I came to Dell, and actually it was a good friend of mine brought me into Dell, and he's a Kaggle master, and so I'd never really participated too much in Kaggle, but I did kind of peanut gallery efforts in some of the tasks that he did. For me, it definitely becomes incredibly time consuming on top of a full time a data job as well too. So
I respect that.
Well, and a family, right?
Yeah, they're unreal. So I got to ask you about one piece of work that you had that I read in your bio, the AES power rankings.
Yeah.
So tell me about this. Tell me how this came about, because it's a numbers guy, a data science guy, but it's something else. What is this related to?
Yeah. So I have a background in volleyball. So I went to the University of Texas, and I was a student assistant for the women's team while I was an undergraduate there. And got really, really fantastic training from a coach perspective, from the head coach that was there at the time. And I thought that's what I actually wanted to do for a living. I was like, I'm going to, be the vagabond volleyball coach. And so I again, very, very heavily involved with USA Volleyball. Decided I didn't want to travel as much. So, okay, I'm going to stay in Austin. I'll be a teacher and a volleyball coach. So I was a high school math teacher and a varsity volleyball coach for 1 year when I realized, not so much my gig. So went back to school, finished up my computer science degree, started in on some graduate school, and then, went to got a job at IBM. But during all that time, I still kept coaching club volleyball. So Austin Junior Volleyball, and so the owner of that runs one of the largest tournaments and is very heavily involved with USA Junior Volleyball. Okay. And so he knew I was a data guy and reached out to me and said, "Hey, David, what about creating a ranking system, like where we can assign points to certain strengths of tournaments?" And I was like, no. If I'm getting involved with this, I want to do it right. And so I said, the only way that you can get true rankings is by head-to-head competition, scores on those competitions, and then any additional data points that we can get around matches that are played. Well, junior club volleyball, you pretty much are doing good with scores. Like if I can get good quality scores and head-to-head, I can solve it. So, I guess probably it's going on now 6 years. I started building it out in AWS so I could scale it across multiple age groups. I think the first year, there were about 10,000 teams, maybe about 100,000 matches. This last year across multiple age groups, male and female or girls and boys, there were over 30,000 teams and over 1 million matches that I'm using to score it. And wow. I don't read the message boards. I know I get some email every now and then about how this isn't how we were ranked incorrectly, or this isn't right. But it's always interesting that whenever I've dove into some of those like one-offs, I'm like, oh, great. So, yeah. So you beat the team that was ranked 5 spaces ahead of you, but you failed to share with me that you lost to the team 20 spaces below you.
Right.
So you shouldn't be above that one team you beat because you didn't, prove consistency. So a lot of the mathematical principles, early ranking algorithms, the chess ranking algorithms, PageRank from Google, use a derivative of that. There's the boosting algorithm, Lambda-Mart is where I ensemble all of those together. I use an ensemble of different ranking algorithms and come up with something, and it's dynamic too. So what I try to do for tournament directors is you have a subset of teams that are going to be playing in your division. And so maybe you only want to use the matches from those teams rather than the global, to be able to get some specific matchups correctly. So it's been a labor of love for mine. Thankfully, with as busy as I've been lately, It's kind of on autopilot mode, but it's always something in the back of my mind that I'm thinking about how I could do a better job with that.
Until like one team changes the date format and completely makes you have to redo the data wrangling.
Oh no. I have so much data quality checks in there. It is like, it's taken years for me to get to where it is.
For a million records, you would have to.
I mean, surprisingly, it runs on AWS every Tuesday morning, starts at midnight, finishes by 4 a.m. And it's been doing that week in, week out for about the last 5 years.
That's really cool.
Awesome, man. Well, that's awesome to hear. One, that that you're actually employed full time in a role that you get to talk about AI and big data, helping data scientists solve unique problems.
Yeah.
Specifically using Dell's workstation technology to bring that that power to right there in their desk, in their cube. That's very cool. And it's even more fun. I love hearing the use cases and that you've been tinkering for a lot of years on something that you're passionate about. That's really fun. But I want to shift gears.
Okay.
We've had fun talking with you about technology and about volleyball. Yeah. But now we want to get a little bit personal with a section we call Rapid Fire.
We've learned a lot from our guests about big data, but now it's time to get a bit personal. In a segment we like to call Rapid Fire. Pew, pew.
All right. So what's the latest book that you've read that you want to share with our listeners?
Oh, so I can't say that I've read a book cover to cover, but maybe I'll take two. I'll do the one that I've read cover to cover and then the other one. AI Superpowers by Kai-Fu Lee. Really good book. Doesn't get into the algorithm aspects of things, but really presents it. So like if you're a data scientist and you're trying to convince your boss or your leader about where AI is going, that's a great book to give to them.
Interesting.
There's another one that I just got, which I was really excited about. I'm not a back-end data guy, but I was like building data-driven applications or something like that. Are you familiar with that?
I've seen it.
Like I read the first like chapter or two and I was blown away. I'm like, okay, I'm not a data scientist. I am a data scientist, but I'm not a back-end data guy. But man, if I ever wanted to get up to speed on how to create a data-driven application, it was a really good book.
All right, good.
Great. So if you had to have a song to play when you walk on stage, what song would that be? Your theme song for going on stage.
Or if you're walking on for a volleyball game, and you want a song playing for you.
Oh man. That's a good one. I don't know if I can I give you a genre though?
Yeah, it's fine.
Okay. Yeah. So I grew up in the 80s. I'm a big 80s hair band guy.
There you go.
So I'd probably have to dive a little bit into one of the Sunset Strip, LA hair bands and pull out one of the classics there.
Good choice.
I think that is the toughest rapid fire question.
It is. The toughest.
It's all downhill. All downhill from here. Wow.
There you go.
Yeah, there we go. So what piece of technology is making your life worse?
Outlook.
Amen, brother. It is a burning trash fire.
No, I am so much like I'm trying to transition people to channel-based messaging, right? And man, if only we could do that, then I'm not. So I say like I play flight.
Flight sims?
Well, no, not flight sims. I'm the flight coordinator, right? The person who's a flight controller, right?
Yeah.
And I'm just sitting here directing emails here and there and adding my bit in. And I'm like, no, we could all do this in a channel. And it's air traffic controller. That's what I was thinking. I'm air traffic. I'm mail traffic controller.
It's not fun.
All right. So moving on, what's your biggest personal money pit right now? Man, I don't really have too much of a money pit. I would say that's a good thing to have.
My personal money pit. If I say my wife loves redecorating, so perhaps that does end up being our money. So that would be no. And she's an absolutely fantastic interior design person, and yes, we'll definitely take care of how the inside of our house looks.
Plus 3 points for that, though. You got it there.
You handled that one because you threw her down there and then you
brought her back up.
Right
there
back up and then put her on a pedestal. That was brilliant. Well done.
So what show are you binging on right now?
I don't watch much TV, honestly.
That's all right.
I would
Yeah.
say,
Yeah.
I would say, the last one that my wife and I binged on was we were very late into the game on Game of Thrones.
Yeah.
And so we actually didn't. So this will be the first season in April that we have seen as it has gone week to week.
Oh, okay.
So we caught the end of last season, binged watched that over Christmas. I want to say, it was a year, or it was. I can't remember when it was. We binged watched the heck out of that. That was
It's a great series to binge watch. It's a lot of time, but it's a great series.
Yeah.
And then lastly, where's the next interesting place that you're going to?
Well, I wouldn't say interesting. I'm heading out to San Francisco area. I mean, maybe that's interesting. But I will say that the last interesting place that I just came back from was a Holy Land trip into Israel.
Oh, that's awesome.
Yeah. So went over there with my church and spent a week over there. And man, fantastic! Like it's a whole other perspective, when just going over there and hearing from tour guides, who can trace their lineage back for millennium, really.
Yeah.
So
That's insane. That's very cool. Well, David, it was super fun to talk with you today. Thanks for joining the Big Data Beard podcast here at the Data Science Salon in Austin.
Oh no, thank you very much for having me on here. I appreciate talking with you guys.
Cool, bud. Thank you.
Thanks for listening to the Big Data Beard podcast.
The music from this episode is by Andrew Belle. Check him out on iTunes or Spotify.
It would also be pretty cool if you reviewed us in your favorite podcast app. It really does help. Thanks for listening.